Hi guys, welcome to MathsCube. Today we are attempting the third question of the Mathematics A paper 1H series. So let's get started. The third question is, the diagram shows a container for water in the shape of prism. Okay, that's the prism shown. And they say the rectangular base of the prism shown shaded in the diagram is horizontal. The container is completely full of water from top to the bottom. The pump starts to empty water from the container at 10:30 and at 12 the water level in the container has dropped by 20 centimeters. So that's 1 hour 30 minutes the water level has been dropped 20 centimeters. Find the time at which all the water has been pumped out of the container. Okay, so looking at the shape of the prism, what we'll do is let me separate it first. We can see that this is 40, this is 60, and this part here has been cut off. So what I'll do is I'll just find the volume separately. So I'll find this volume first and then this volume. So to find the volume will be equal to cross-sectional area, that's written as CSA, into length. And one pro tip I can give, that the length is already been given and that's 125, and we have to do absolutely nothing to find any of it. So length is already 125, so we have to find cross-sectional area of both these rectangles separated above and below. So to find the volume of the bigger part, what I'll do is I'll just take 85 and multiply with 40, and then add it with 30, the product of 30 into 20. So that will give me this area here, this area. So we will get the cross-sectional area, and to get cross-sectional area, as I said, I'll just write down the values now. There you go, 40 into 85 plus 20 into 30, and the product is 3400 plus 600. Adding these together will get me 4000. And now to get our ultimate value of volume, as we know, we have cross-sectional area, we have length, so we can find the volume now. There you go, 4000 into 125 will give me the whole volume of the rectangular prism, and that will be 500,000 centimeter cube. That's the total volume of the both of the prisms. Now going back to the diagram, they say in the question that the pump starts to empty water from the container from the top, from here, it's from here, at 10:30 and at 12 the water level of the container has dropped 20 centimeters. So it's been dropped from here, this all water has been gone. So what we'll do is one more piece of information, if we know this length here, this length is 125. So what we can do is find the volume of this area, and then we can find out how much water was left from the whole pump. Then we'll use volume formula, L into width into height, L is length. That will be 125 into 20 into 30, and that will give me 75,000 centimeter cube. So that's the volume that has been pumped out of the container, and we have to find out how much time it takes to pump out 500,000 volume of the container. We can find the time also. So 10:30 to 12:30 is 1 hour 30 minutes or 90 minutes. So 1 hour, 1.5 hour. The water level had been dropped to 20 centimeter. Now we can do the comparisons that 1 hour 30 minutes or 130 hour can make 75,000 centimeter cube of the water being pumped out of the container, and that's 20 centimeter in height. So how much time will be needed to just completely pump out the container or the whole of the volume? That's 500,000 centimeter cube. So what we'll do is we'll just cross multiply, or you can say 500,000 multiplied by 1 hour 30 and divided by 75,000. So I'll write it again. So T equal to 500,000 into 1.5 upon 75,000. And why did I write 1.5 instead of 1 hour 30 minutes? Because 30 minutes are 0.5 of 60 or 1 hour, and the product of 500,000 into 1.5 will give me 750,000. Just cancel these to simplify. Just cancel these zeros. Now we are left with 750 by 75, and 75 divided by 75, that's 1. That's, we're left with 1. So our answer is T equal to 10 hour, and that's the time at which all the water will be pumped out of the container. So guys, thanks for watching. If you like the method, do subscribe and stay tuned for more videos from this series.